First, plug the 5-volt source into the Arduino by using an adapter and then connect the 220-volt line. Switch on the adapter for Arduino and here we go, our AC power slash energy meter is ready. Hello guys, welcome back. Here is our setup to AC power monitoring using BL0940 series IC and it works in the first go. Let us see how. Welcome to Altium. Now with Altium you can build together with your team and work on the same project. Altium became the industry standard tool to provide schematic to full PCB solutions. If you are working professional or a student, you can learn PCB design from basics and grab a certification from Altium. There is a full course available for free. Enroll now and build the basics with industry standard techniques. Here is the schematic for BL0940 that I have designed in Altium. You can see the first section contain the current monitoring part with a sense resistor in series. See the line and neutral part written here for 220-volt connection. And finally the signal conditioning part here. And here comes the main IC BL0940 which is powered by the onboard LDO AMS1117 3.3 volt. And here is the filter for voltage input part. The voltage monitoring feature is also inbuilt in the IC. Using the resistors and a low pass filter, you can use the same values or calibrate later on with the data. The voltage monitoring pin is connected as VP. Here comes the PCB part. The PCB is designed keeping space constraint in mind, but with a modular approach, it will help easy connection through breadboard and can fit into small housings. As you can see here, I have chosen all the SMT components, placed the IC in the middle, and with the spotted electronics. You can even make more thicker traces, but in my case, these are desirable. Finally, I shunted out the conditioning, which can be done directly through the current sense resistor here, but the IC is self-calibrated. I do not need to care for more precise part or strict layout rules. Here, header is placed in the bottom side and voltage resistor on the left side. Here is a 3D view. This is how the PCB looks. I have used the external software for now to visualize the 3D structure of the populated PCB. Then I fabricated the one using a nearby manufacturing service and see how the PCB looks. It's clean and ready to solder. After soldering, I do tested it out without any calibration just to check everything works and it worked in the first go. However, the isolator for SPI did not work, which I removed in the final revision of the PCB, but it is showing inaccurate results for now and we have to calibrate it. And see, after calibration it works with a 100-watt load. The exact reading for which I am looking you can see here on the screen. So to calibrate the IC first, I have created an Arduino library for BL0940 in which you can find the calibration and working code in the example section. Because I'm using SPI protocol here with this, you can make the Arduino connection as per the circuit diagram with the GitHub repo given in the description of this video. In the calibration code, before uploading to the Arduino, change the load info and it should be precise and measured using any multimeter. You can say there is a 100-watt load, so you have to change it. The known load in my case is a 100-watt bulb. You need a known 100-watt bulb load. Then connect the wire to the 220-volt AC. Keep in mind the line and neutral connection. It will turn on the bulb and finally plug the DC jack for 5 volts. And you can see the calibration screen is here showing the variables to manipulate in the main code. Note down the values that are shown on the screen. Now upload the main sketch with the changed variables and you will see the calibration is done. Now testing can be done using different loads. Here is one smart bulb of 9 volts. Let's plug it in. See the results on screen. Here is the other one of 14 watts and you can see the results for it also. Keep in mind when working with a 220-volt, do not plug Arduino directly into your laptop or computer. Use the external power source. First you have to program the Arduino and then connect it with other power source like adapter. This is all from my side. If you like the content, comment down your ideas how you can build with this circuit and see the description of this video for the more info.